Hi, Assalamualaikum and good morning to all Bagan Jaya student 5A, 5B and 5C. So I hope you are fine. So this morning will be our final session, our last lesson on PDPR, home-based learning. Okay, and today as you can see, I am not alone. I have a special guest with me today. I don't know either you recognize these people or not because they are actually your seniors. Okay, so we are very lucky today. So since this is the last session, so I want to make it a bit special. So I have invited two of your seniors from batch 2018, right? You're from batch 2018.
Yeah.
So
Yeah.
they will share with you some tips and some experience on how to be well prepared for your SPM examinations. Okay, and you also can say hi to them, or if you want to ask them any questions or want to interact with them lively, you can join us in this stream by clicking on the link which I paste just now. Okay. So we begin with who first? Jensu or Zanquan? Siapa nak mula dulu?
I think Jansil can go
Yeah.
first.
Jensu. Okay, Jensu. Okay, so this is Ong Jensu. Okay, maybe some of you know him. He is one of salah seorang pelajar cemerlang kita 2018. Okay, congratulations Jensu. Okay, you got straight A
Okay.
last time, right? Is it?
Yes.
Straight A's for 11 subjects, is it? 10.
10.
10 subjects. Okay. So Jensu is now studying in USM, University Science Malaysia, in engineering campus. Okay, he is now doing chemical engineering, right?
Yes.
First semester chemical engineering. And for your information, actually he is my junior in USM. He went to the same campus I went before. So I am his super senior. I'm also doing chemical engineering last time in USM. Okay. So if you found any of my photo there, so you can tell this is my teacher. Okay. Okay. So Jensu, can you share some tips with your junior here? Maybe on what do you do when you are prepared last time when you are preparing for your SPM? How do you manage your time when the exam is just about around the corner? Boleh kongsi tak sedikit tips yang
So
kamu guna? Okay.
I will share with you guys some tips you need to do before SPM. So firstly, I would suggest you guys not to stay up until midnight and do revision. Try to do some revision as early as possible during the daytime so you don't panic, okay? Secondly, when you do the revision, I want you to put away of the distractions such as social media and games. Then next, you guys should take care of your mental health and physical health. Try to do more exercise and jogging. And lastly, I would suggest you to have a good time management to revise every 10 subjects that you are going to take, okay? So, if you want to motivate yourself, I would suggest you guys to do more past year and trial papers from different states. Okay, try to do all if possible since you guys have a lot of time. When I take SPM, I have only 10 months to do revision, but you guys have 1 year, okay? and it's a very good opportunity for you to do a proper revision chapter by chapter. Before you start your exercise, you try to do a proper revision, chapter by chapter carefully, and then you when you start after you complete each paper, you try to check your weaknesses, every weakness, every mistake that you do, and you come up with a solution how to solve it. So that's all for me. Thank you.
Okay, so just now, thank you very much, Jensu. So Jensu just shared to us a few or some tips which I think beneficial for you. So which one you think you can adapt with yourself? So you take it positively. And I have one question for you, Jensu. Last time, what is the biggest obstacle that you used to face when you are dealing with physics, and how you handle that matter? Uh, Even though
I think
you don't have any problem with physics actually, but sometimes maybe you feel the stress is there. So I mean, how do you cope with that stress?
so. I think physics in SPM is basically not too difficult. But sometimes you may make some silly mistakes. Uh, if you want to, this is the obstacle for me. So if you want to overcome it, um, you try to do the partial lip, and keep in mind yourself. Be careful. Not only physics but also other subjects. Okay. If you
Okay.
yeah, that's all for me.
Okay. Okay. So, Jinsu say, you try to do as much as possible for the different trial state papers
Uh,
for SPM. This is also what I suggest to them, and I have shared with them a few sets of a different state of SPM trial this year. Okay. So, now we go to Zanquan. Okay. Good morning, Zanquan.
Yes.
Okay,
Good
okay.
morning,
So
madam.
Zan Kuan also one of our excellent student in 2018. You also score straight A, right? Is it right? Straight
Yes.
A's.
10,
10
10
A's.
A's.
Okay, congratulations for that. And last time he is not only good in academics but also participating in aquatics, right?
Yes.
In some years. So it shows here, it doesn't mean you have to concentrate on your academic thing only, but it is better for you also to be active in the co-curricular activities, as long as you know how to manage your time well. Okay, I think that is the key. So Zan Kuan, anything you would like to share with your juniors?
Okay. Hello, everybody. I'm going to share my tips on how to face your SPM. Okay, so first of all, I think my point is almost similar with Jensil, but still got some difference. Okay, so the first one, the most important one is your time management. You must have time management. For example, you never study until midnight, 3 o'clock, 2 o'clock. Never sleep late, because if you sleep late and wake up in the morning you don't have any spirit, you are demotivated to study. So you must find your way. Ask yourself that, are you a night owl or a morning study lover? So like me, last time I'm a morning study lover. So I wake up at 5 in the morning and I start to study. And I study for like 2 hour, 1 hour. So I go to jogging, I go to swimming, relax myself, doing some exercise after you study in the morning. Okay, so this one is how you prepare yourself in SPM. In the same time, you also don't get any stress by doing your own hobbies. Okay, so the second one is do the trial question as more as you can. For me, last time I do the trial questions from all the state, but I limit my time. For example, NMAX, the examination time given is 2 hours and 2.5 hours, right? So I
Yeah.
limit my time. I limit like I only complete it in 1 hour, 30 minutes or two hours. You must limit your time because later in SPM you will be nervous and you will think too much and don't have time to complete all your questions. So you must limit your time. Okay. And remember, when you do the trial question, you don't refer to any reference book. Okay. So before do the trial, make sure you know all the topics already. And then the last one, you must make sure that your mental and your physical is in very healthy condition. Because if you prepare 100% and then during SPM or you sick, so it will affect your performance during the exam. Okay, so make sure that you are healthy. So I think that's all for me. The 3 tips to face SPM.
Okay, so thank you for the wonderful tips. But I have one question for you, Zanquan. Actually,
Yes.
some of our students, okay, when they're doing the trial sets for different state, if the answer is not there, they feel reluctant to do it because they have nothing to refer at, nothing to refer to. They refuse to do that paper, mean not motivated to do. So what do you think about that?
So for this kind of question, like you don't have any things, you don't have any resources to refer. So this kind of question is actually a good question for me. I really like this question because when you study one thing, you not only do it for your exam, not only for SPM, you do it
Yes.
for your own knowledge. So if you
Yes.
study it, you gain all the knowledge yourself, and not for your teacher, not for your family, not for SPM,
Mhm.
for yourself.
Mhm.
So when you next time you see this kind of question, try to do it because you are do it for yourself.
Mhm. So I think that was a very good tips, okay, a very good sharing. And for your information, both of them actually went to the same matriculation center after their SPM. They joined the matriculation program in Gopeng, right? In Gopeng, Perak.
Yeah.
Okay.
Yeah.
So can you share some experience while you are in matric? How is it life in matriculations? And do you suggest them also to go to matriculations after SPM?
Okay. Let me say first. Okay.
Okay.
First of all, during my batch, all my classmates were applying matriculation. Our target is matriculation, all of us. So I assume that for this batch, 5A, 5B, 5C, also matriculation is your target lah. Okay, so I'm very recommend you all to study in matriculation. Okay, why? Because matric is a fast track for you to enroll in university. Okay, not only local U, because I heard that before I enter matric, I heard that if you want to study overseas, you go to study A level or what. So matriculation actually is a way for you to study overseas as well. For one of my friend also after for my batch matriculation, my batch in matriculation, he now using his matric result study in China. So actually can study overseas as well with matriculation qualification. So I'm going to share my life during matric. Yes, it's very fully compact timetable. You don't have time to rest except sleeping. So and then you also learn many soft skills. For example, organize an event. Okay, organize an event, time management. You must become a multitasker. Okay, doing two tasks above in the same time because it's very busy life at there. And then in matric you must discipline enough because compared to secondary school in matric is almost same like the life in matric is almost same like university. You are very freedom at there. So you must discipline enough, study all the subject yourself, do revision, do exercises. Yeah. So that's all. I think still got many and you guys can ask us in the comment box later.
Okay. Okay. So how about Jensu? Can you share some of your experience in matriculations program last time?
I think what I want to say is similar to Zhang Chuan. Uh, basically, matriculation is the most preferred path to university. If you want to get a better course, and it's really fast. Last time we started from May until April this year. So it's very fast compared to STPM where you have to take almost 1.5 year. If you join matriculation, you can join many events and activities which are very fun and you can know many people. And in matriculation, what I want to share. I think most of things are said by Zhang Chuan, so that's all for me.
Okay. So your final words to them, our SPM candidates 2020. Maybe some short
So
final words to them.
in short, I think you guys must try your best. This is the only chance for you to sit for SPM. Don't think that you can take any retakes. Do your best to do to the maximum. And that's all for me.
Okay, thank you very much. And Zankon, and any last word from you, maybe?
Okay. So I want to suggest my juniors, you can start to think that your life after SPM, plan your own goal. Like not only I want to score 10A, I want to score 10A plus straight A. Not only this, you must set your goal as high as you can. Like what you want to be. You want to be an engineer, you want to be a lawyer, or you want to be a doctor. So if your target is set there, then you will be motivated to study. Okay, so good luck in this SPN which coming soon. Good luck in 222, 22nd of February. Yeah, you still
Yes,
have time to
22nd
study.
of February.
Okay? Believe yourself, you can make it.
Okay. Okay. Okay, so thank you very much again to Jensu and Zanquan. So it's a very great opportunities to have with you with us today. So I hope whatever they have shared to you just now can be one good motivation for you. And because when you are studying, as they say, don't only study for exam, don't only study for A plus, but study for the knowledge. Because this is the knowledge which will guide you along your path in your life journey. Okay, so SBM is just a stepping stone for you to face the real world out there. Still many awaits you in the future. So in school, actually, all teachers, we are preparing for you, like molding yourself to be a person so you can cope with the real world out there. So again, thank you very much to both of you. I wish you all the best for your study. In the future can be a good engineers, okay, which can benefit to the country, to the people, and to everyone. Okay, so again, thank you, Jensu and Zanquan. So class 5 Akid, 5 Baiduri, 5 Citrin. I hope this short sharing session will be a new motivation for you. Maybe some of you now feel down, feel demotivated because of this MCO. So I hope by what we are doing today can rise back your spirits of doing well in your SPM later. Okay. So we are about to begin with our lesson now. So I hope you are ready with your module. Okay. So my slide is showing the remaining question and module 2, question 14 and question 15. So we finish with this question first before we go to the third module, module 3, the final module for our revision session. Okay. So class, are you ready? If you are ready to begin, can you please show me some sign? You are very silent today. So who are with us today? Okay, so module 2, we continue with question 14. Okay, so this is the last two questions, question 14.1 and 14.2. It shows electric circuit contains two identical bulb which has resistance R. Okay, and they are connected to a new dry cell of 1.5 volt. Okay, good morning, Jinje. Okay, current flow through the circuit to light up the bulb. So in this diagram, you're given 4.1 and 14.1, 14.2. You can see there are two bulbs in each diagram and they are identical. Okay, so the first question, what is the meaning of current? So guys, what current refers to? What is current refers to? Okay, 1 mark for the definition. Okay, you can share your answer as usual in the live chat. So current refers to rate of flow of charge. Okay, rate of flow of charge. Okay, then B, 5 marks. Questions on comparison and forming a relationship. So using diagram 14.1 and 14.2, number 1, compare the brightness of the bulb. So you can highlight, you can write them mark 1. Mark number 1, compare the brightness of the bulb. Second, compare the effective resistance of the type of circuit. And then number 3, compare the reading of ammeter. Okay. And then next, relate the brightness of the bulb to the reading of the ammeter. And number 5, to write or to deduce the relationship between the effective resistance and the magnitude of current. So these are the 5 points you have to deal with. So again, I advise you to highlight or to underline all the needs of these questions. Okay, so how we compare the brightness? What can you say about the brightness of the bulb in 14.1 and 14.2? So you can say bulb in diagram 14.2 brighter. Okay, brighter than that in 14.1. Okay, that is the first comparison, 1 mark. Okay, second, you compare the effective resistance. So, 14.2 is less compared to 14.1. My first point, I started with 14.2 at the front. So, my next point, I continue writing 14.2 at the front. So, later, easier for me to write the relationship. Okay, and then number 3, compare the ammeter reading. So, in 14.2, ammeter reading is higher compared to in diagram 14.1. Okay. You can either use the word or you can use the mathematical symbol for greater or lower than, less than. Okay, then number 4, the relationship. So the greater the magnitude of current or the higher the magnitude of current, so the brighter the bulb. Okay, this is the relationship. And the second relationship, the lower the effective resistance, the higher the magnitude of current flow. Or you can say effective resistance decreases, magnitude of current flow increases. So this is how we tackle the 5 marks questions. 3, comparison, 2, relationship. Okay. Okay, next question C. So by using appropriate symbols, draw an electric circuit diagram for each type of circuit connection in diagram 14.1 and 14.2. So actually in diagram 14.1 and 14.2, we have series and parallel connections respectively. So you just draw the symbol for the electrical appliances for both diagram. This is for 14.1. It is a series connection. And in 14.2, the bulb are connected in parallel. Okay, so there the switch, the cell, the ammeter, and the bulbs in series in 14.1. And in 14.2, cell, switch, and ammeter is at the same place. Only now the bulb is are arranged in parallel. So by this, it secure you 2 marks. Okay, the symbol. Okay, next in question 14.2. Explain what will happen to the magnitude of current flow through the circuit in diagram 14.2, actually 14.2. When another identical bulb is connected parallel to the both bulbs. So now in 14.2, we connect 2 bulbs in parallel. So what happened when we add another bulb? Now make it 3 bulbs in parallel. So what do you think will happen to the magnitude of current flow through the circuit? Any changes? No changes? Increases or decreases? What do you say? Read the question carefully. What happened to the magnitude of current when we add the third bulb into the parallel connection in 14.2? So what do you say? What happened to the magnitude of current? First, you can talk about the effective resistance, the total resistance. When you add more bulb in parallel, so it will lower down, it will reduce the effective resistance in the circuit. Okay, so what happens when effective resistance decreases? Definitely the current flow will be higher. Okay, magnitude of current flow increase. So this is how we write our explanation for 2 marks. Okay. Okay, next, 14.3, you are given another diagram. Okay, this diagram, it shows a bulb. Okay, here it labeled the gas inside, and the bulb is made from a straight, thick wire filament, and down here is the contact points. All right. So it says that the bulb in diagram 14.3 is going to be used to light up at larger area. Okay, so you have to explain the modification which need to be done to increase the brightness. So you are fixing this bulb in a larger area, so it has to be brighter, so it can uh, generate more light to that larger spaces. Okay, so it can give a brighter light to a larger spaces. So in your explanation, you have to be focused, emphasize on these aspects. Number one, the shape of the filament. Okay, so modification number one, shape of the filament. Okay, second, the thickness of the filament wire has to be thick or has to be thin. When we talk about the shape of the filament, either straight wire or coil wire. Okay, that is the normal shape that we have. Either straight wire or use coil wire. Thickness, thin or thick wire. And then melting point, high or low. Gas pressure inside the bulb has to be low or need to be high pressure. And then finally, the material used for the contact point. Okay, what material is suitable to be used for the contact point? Somebody is replying here. Arif Weiliang decreases. Which one? Which question you refer to this? I think the previous one. The effective resistance, the total resistance decreases, which means it will be the magnitude of current will be greater. Okay, if in parallel, when we add in the third bulb in parallel, so the total resistance in the circuit will be decreased, which means current will be greater, magnitude of current will be higher. Okay, Arif and Weiliang, are you clear with that? Okay, so now we go to the modification and explanation for bulb in diagram 14.3. Okay, first, the shape. Just now I give you two choices. The shape of the filament. You want to use a straight wire or a coil wire to be fixed inside the bulb. So we choose a coil wire, a coil shape of filament. Why? Why choose a coil-shaped filament? So that the length of the filament will be longer. Okay, coil shape. Yes, very good, Vinci. Coil shape. Why coil shape? So coil shape, the wire will be longer. Okay, so when the wire is longer, resistance will be higher. Yes, very good. Increase the resistance. Okay, to increase the resistance. Mean more heat will be produced by the filament, so it will be brighter. Okay, next, the thickness. So choose a thick or thin wire. So we choose a thin wire. The filament wire must be thin. Why? Again, to produce high resistance. So to produce more heat effect in the filament and cause it to be brighter. It will light up brighter. Okay. Next, melting point. Okay, melting point. So we choose a high melting point of filament material. Okay, why must be high melting point? So it does not easily broken. Okay, tak mudah rosak. To avoid the bulb easily blow up. This is the reason of choosing high melting point of filament wire. Okay, then talking about the gas pressure inside the bulb. Okay, the gas pressure must be high or must be low. Okay, the gas pressure inside the bulb must be low. Why? So to prevent explosion. Okay, when the gas in a high temperature, to prevent our bulb from easily blow. So we insert a low pressure gas inside. Normally we insert an inert gas. Okay, inert gas are in group 18 of the periodic table. For example, argon. Okay, argon gas. Okay, then material used for the contact points. Okay, the contact points below. It should made from metal. Yes, ginger, low gas pressure. Okay, so the material used for the contact point need to be metal. Why metal? So it is a good electrical conductor because you have to fix the bulb, okay, into its casing and to be connect to the electric plug. So it has to be made from metal for good electrical conductor. So these are all the modification we can do for the bulb in diagram 14.3 with the purpose to for it to brighter to light up a larger area. So dia boleh terangkan kawasan yang lebih besar. Okay. Okay, now we move to question 15, the final question in module 2. Okay, diagram 14.1 shows a bird perching on a high voltage cable, okay, that transmit electrical power to the consumer. Okay, so I think you are familiar with this question. This is actually a past year SPM questions. Soalan SPM yang lepas, but I didn't check which year, but it is SPM past year question. So first, what is the meaning of power? So power, what is the meaning of power? Power is rate of energy, rate of work, energy per time, work per time. Okay, power is energy divided by time, the formula. P equal to E divided by T. So the meaning we should write in words, rate of energy or rate of work done. Okay. Okay, second, okay, based on diagram 14.1, the bird does not experience an electric shock. Explain this situation in terms of the length of the cable between the bird's leg and the potential difference across the leg. So why the bird keep safe even though it is sitting on a very high voltage cable? So what happened? So you have two choices of answer, how you can write your answer. They give you two alternatives. Okay, the first alternative, you can talk in terms of the length of wire. Okay, so the length of wire, we refers to the length of wire in between the bird's legs. Okay, look at the length of wire in between the bird's legs. It is very short. Okay, the length is very short or small, length small or length short. So what is the resistance? For short wire, the resistance is smaller. Okay, there are small resistance there between the two legs. So R low, resistance low. Okay, so the potential difference also low. Okay, the potential difference also low. So by doing low, so it doesn't cause any damage or any harm to the birds. Okay, one mark for each point. Okay, or you can also answer in this way. Okay, you can talk in terms of the body of the birds itself. Okay, the body of the birds is a poor electrical conductor. Okay, or it is an insulator. Okay, an insulator has a very high resistance. So by this, the voltage across the two legs is zero. Since the resistance is very higher, so no current flow in between those two legs. Okay, so alternative 1 in terms of length of wire and alternative 2 in terms of the body of the bird, which is act as an insulator. Okay, so that goes for question A2. Okay, now we move to question B, a long essay question. Okay, now 15.2 show the design and a characteristic for 4 different circuits. Study the specification of all 4 circuits. So let's take a look at the 2 circuits. First, we have circuit J and circuit K. There are 2 electrical appliances there. First, you have a kettle, then you have a toaster. Okay, what can you understand in circuit J? Okay, this connection wire is a thick wire. Okay, and the voltage supply is 200 volt. There is a fuse of 15 ampere here. And this is the toaster with the voltage, with the required voltage 240 volt and power 2 kilowatt. While the electric kettle require 240 volt to operate and the power produced 2.2 kilowatt. Then you look at the connection. Okay, how is this kettle and toaster are connect in this circuit? They are connected in series. Okay, they are connected in series. While if you look at circuit K, we also have kettle and toaster. The connection wire is thick. The voltage supply here is 240 volt with a fuse of 20 ampere. So this is the voltage required for the toaster to operate, for the kettle also, and they are connected in parallel. Okay, you can see the toaster and the kettle connected in parallel. While for L and M, L, the connection wire is a thin wire supplied to a 240 volt, fuses 20 ampere. Again, kettle and toaster operate at 240 volt with power for each. Okay, and M, connecting wire is thin wire supply, connect to a power supply of 200 volt, fuse 15 ampere is fixed there. Again, the voltage required for both toaster and kettle is 240 volt, and their produce power of 2.2 kilowatt and 2 kilowatt respectively. Okay, so you have to understand what do you have in all this circuit. Okay, so what is the question? Explain the suitability of each design and the characteristic of the circuit to determine the most suitable circuit to enable the electrical appliances to work efficiently. Okay, give a reason for your choices. So the information are given in diagram. Dia bagi maklumat dalam bentuk diagram. So you have to transfer from diagram into words. So first, what can you write? The wire. Okay, the wire used should be thick or should be thin. This is the connecting wire. Okay, it's not the heating wire. So the connecting wire for the circuit, it has to be thick. Why? This is to reduce the resistance along the connecting wire, so to produce less heat, reduce energy loss. Okay, so this is all the explanation you can write. Low resistance, small heat produce, withstand heat, low energy loss, low heat loss, high current, total resistance low. Okay. Second characteristic, how much voltage must be supplied? You have two choices, 240 or 200 volt. So we choose a high voltage supply, which is 240 volt. Why? Because this is the required voltage for both toaster and kettle to operate. They only can operate at the voltage of 240 volt. If you check on the label just now. So voltage same with the appliance rating. Appliance normal work. They work normal at this voltage. Okay. And third, the connection of both kettle and toaster. So they are better to be connected in parallel. Why? So if one of those appliances not working, the other still can function. If the toaster is spoiled, the kettle still can operate. Or if the kettle is burned, the toaster still can be used, still can work. Okay, or you can say effective resistance will be small. Okay, so this will generate high current in the circuit. All right. Okay, and then the fourth characteristic, the fuse. Okay, you are given two choices, a fuse with a bigger or a smaller ampere. So we choose a fuse of 20 ampere. So actually here you have to do a bit of calculation to determine which use to be applied. Okay, if you calculate the current flow in the circuit, okay, when given the voltage and the power, the total current flow in the circuit is 17.5 ampere. Okay, 17.5 ampere. So the fuse has to have a greater value than this current, which means it must use a fuse of 20 ampere. Okay, first you can write what is the uses of this fuse. What is this fuse used for? It is used to break the circuit when the current flow is bigger than the fuse limit. Means when there is an overloaded current, so the fuse will melt. The fuse will melt, so to protect the electrical appliances from damage, from spoil. Okay. So which one is a better choice? Which circuit is a better choice? So we choose circuit K. Okay, why? So you can write all the characteristic of circuit K. It used thick wire supply with 240-volt, fuse of 20 ampere, and the kettle and toaster are connected in parallel. Okay, so I hope you are clear with the characteristic and explanation for this purpose for this question. Okay, now question C. 5 question. Okay, diagram 14.3 shows a circuit consisting 2 resistor and a bulb. So the resistor is 5 ohm and 20 ohm respectively. Okay, this is the cell 12 volt ammeter. There is a bulb here and a voltmeter is connected to the bulb. And now there is switch S here. Switch S is now in an open position. Open position. Open position means the switch is off. Okay, so you have to calculate the resistance of the bulb. Okay, before that, there's an important information up here. The reading of the ammeter is 1.5 ampere when the switch S is off. So you can highlight this information. Okay, when switch S is off, as shown in the diagram now, the ammeter reading is 1.5 ampere. So which means that when S is off, the current only flow in the first junction. Okay, since S is off, so this circuit is not connected, so current only flow in the first junction. So by this, find the resistance of the bulb. So how we find the resistance of the bulb? So in this path, okay, we have a bulb and we have a resistor. So the resistor and the bulb is in series. Okay, they are connected in series. The 5 ohm resistor and the bulb is connected in series. So to find the total resistance, so you have to add 5 ohm plus the unknown resistance for the bulb. So how to find the unknown resistance of the bulb? So we use this equation. R equal V divided by R, Ohm's law. So R is referred to the total resistance of the 5 ohm and the resistance of the bulb. Okay. So here we know the resistance is 5. So the bulb we don't know, we want to find. So we label it as RB, equal to 12 volt. The voltage supply is 12 volt and the current flow is say 1.5 ampere. Okay, so by this, the resistance of the bulb is 3 ohm. Okay, 3 ohm is the resistance of the bulb. And then second, find the reading of ammeter and the voltmeter when switch S is now on. Okay, now on mean this switch is closed. So you close switch S. Okay, there is a connection in this path. Okay, and now 5 ohm and 20 ohm resistor are in parallel. Okay, these two are parallel, and again our bulb is there. So you have to, you are now have a combination circuit of both parallel and series. So how to find ammeter and voltmeter reading in a combination circuit? Okay, so how to do this? First, you must find the total resistance in the circuit, the effective resistance in the circuit when switch S is now on. Okay, so how to find the total resistance? I label it as RT. So for the parallel resistor, this is the total resistance 1 over R5 plus 1 over R20 and then reciprocal of it. Okay, plus RB. So B is connected in series, resistance of the bulb. Okay, so this is the formula. So this will give you 4. Okay, the total resistance for both 5 ohm and 20 ohm is 4 plus 3 resistance of the bulb. So total resistance in the circuit now is 7 ohm. Okay, 7 ohm. So now we can find the ammeter reading. Okay, ammeter reading, current V divided by R, voltage multiplied by resistance, where the voltage is 12 and the total resistance is 7. Okay, so 12 divided by 7 will give you 1.714 ampere. Okay, so which means when switch S is closed or on, so now the current flow in the circuit is 1.714 ampere. Okay, 1.714 ampere. Okay, and then how to find the voltmeter reading? So this one you have to see where the voltmeter is connected to. The voltmeter is connected to the bulb. So you must know what is the current and resistance in this bulb. Okay. So how to find the voltmeter reading? So V equal IR. So what is the current flow to the bulb? 1.714 multiply the resistance of the bulb is 3 ohm. So by this, the voltage of the bulb or the voltmeter reading is 5.142 volt. Okay, 5.142 volt. So I hope you have tried this question before and you are able to find the correct answer for one, resistance of the bulb, the ammeter reading, and the voltmeter reading as well. Okay, the most important, you must understand the circuit. What type of circuit you are given? Okay, parallel, series, combination. How to find current, resistance, and volt in each of these circuit, either series, parallel, or combination circuit. Okay. Okay, so that's all for module 2. Okay, for module 3, I have sent them in your Telegram and WhatsApp group earlier. So I hope you already get it and you can download from there, or you can focus on the lesson first. So later on you can get the question. Okay, so now we are discussing question 1, 3, 5, 7, 9, and 11. Okay, so question 1. Okay, this third module is on electromagnetism, electronic, and radioactivity, the last 3 chapter. So diagram 1.1, diagram 1.2 show the pattern of an electromagnetic field formed by iron filling when the solenoid are connected to the battery. So you can see 1.1. Okay, this is the solenoid. This is the cell down here. You can see where is the current flow from, in which direction the current is flowing, and we place a compass P at this side. Okay, so this is the pattern formed by the iron. feelings. Okay, and for diagram 1.2, okay, this is the pattern of the field shown by the ion fillings, and this is the connection of cell below. Okay, so what is the question that follow? What is the meaning of electromagnet class? What is the meaning of electromagnet? Okay, what is electromagnet? Okay, this is a very straightforward question. You have answered it for so many times. Electromagnet, what is it? Temporary magnet. Okay, very simple. Electromagnet is a temporary magnet. Okay, now let's take a look at question B. Okay, I want you to try to answer this B. Share to me your answer. A plotting compass is located at P in diagram 1.1. So by using an arrow, mark the direction of the pointer of the compass. So before you determine in which direction the compass will deflect to, you have to look in which direction the current flow along the solenoid. And then what rule to apply for us to see the pattern of magnetic field produced. So what rule is applied here? To determine the magnetic field of a solenoid, what rule we apply? Right hand grip rule, Fleming left hand, or Fleming right hand rule? Which one? Anyone? We have solenoid there to determine the magnetic field pattern. So what rule is applicable here? So we apply right hand grip rule. Okay, right hand grip. So if you look at this circuit carefully, so current flow in this direction. Mean at this side, the current flow out. Okay, at the coil at the front, the current flow, yes, right hand grip rule, very well. Okay, at this side, current flow out. Okay, flow upwards. And at the other side, current flow into the plane. So by applying the right hand grip rule, at this side, you should place your thumb in an upward position and see the 4 curl fingers. Where does it curl at? Clockwise or anti-clockwise? Okay, for the front part. Okay, when your thumb is pointing outwards, it shows the direction of current, thumb pointing upwards. So your curl finger curl to where? Curl in a clockwise direction or anti-clockwise direction? Okay, which one? At the front here. Thumb pointing upwards. So curl finger follow the clockwise or follow the anti-clockwise rotation class at the front? Clockwise or anti-clockwise? Yes, Yutong, is it right hand grip rule? Very good. Vinci, right hand grip rule. Jinjae, Dylan also say right hand grip rule. Okay, at the front, clockwise or anti-clockwise, you can place your right hand grip rule there. So you can see the rotation is anti-clockwise, right? While at that side, at the other side, where the current flow into paper. Okay, the current flow into paper. So our thumb pointing downwards. So you will see your curl finger curl to the clockwise rotation. So by this, you can draw. You can draw. This arrow show the rotation of the curl finger. For the front, it is anti-clockwise. And for this area, it is clockwise rotation. So for compass P, where will the needle pointer pointing at? So it will point to the left. Okay, it will point to the left. Okay, very simple by applying right hand grip rule. Okay. Okay, next question C, based on diagram 1.1 and 1.2. Compare. Okay, now you have to compare the number of turns of the coil. So which one has a greater turns, which one has a less number of turns. Okay, this one you can see obviously. Diagram 1.2 greater. than 1.1. Okay, number of turns. And then number of iron filling lines, you can see here is denser, or you can say more. Diagram 1.2 greater than 1.1. Or you can say diagram 1.2 denser than 1.1. How about the magnitude of current passing through the solenoid? Okay, so definitely the same. Okay, magnitude of current. So they are supplied with the same uh, okay, there is an identical cell below here, so they supply with the same amount of current passing through both solenoid. Okay. Then D, state the relationship between the number of turns of coil and the strength of magnetic field. So what happened to the magnetic field when the number of turns greater? So number of turns increase or number of turn greater, strength of magnetic field increase. Okay, strength of magnetic field higher. Okay, so if this a structure, you can just write increase, increase. Okay, if it is a structure question, you can say increase, increase, higher, higher, greater, greater. But if it an essay question, then you must come out with the full sentences. Number of turn increases, strength of magnetic field increases. Okay, and then for question E, explain what happened to the string of electromagnet if a soft iron core is inserted in the solenoid. So now we add a soft iron core, okay, into the solenoid. Why the strength of electromagnet increase? Okay. Normally they ask you what is the function of the soft iron core. So you can write to increase the magnetic field strength. But now they ask you to explain why when you add on a soft iron core, the magnetic field strength is increases. So what happened? First, what happened to the strength? So you can say the strength increases. Okay, the strength of the strength of electromagnet increase. And then why? Remember, they have you to explain. So there is a why there. So why? Because by adding a soft iron core, it will help to concentrate the magnetic flux or to concentrate the magnetic field. Okay. Okay, then question 3. Question 3. So now we are discussing the odd question 1, 3, 5, 7, 9, 11 because we don't have enough time to discuss all. But you don't have to worry. I will give you the full answer for all questions in this module later. Okay. Okay, diagram question 3. Diagram 3.1. It shows a relay. Okay, relay is the one application of electromagnet used in an electrical circuit. First question, what is the function of a relay? So what is a relay used for, class? Relay switch. What is the uses of relay? Anyone? Relay used for what? Okay, this relay switch is used to switch on a high current or to switch on a high voltage circuit. Okay, so a smaller circuit will switch on a larger circuit. Circuit connected to a higher voltage or higher current. Okay, that's why we call it as a relay switch. It's a connecting switch. Okay. And then second question, A2, explain what will happen when an electric current flow in the main circuit. Okay, normally in relay circuit, okay, we have two circuit, main circuit and then the relay circuit. Okay, the current that flow in the main circuit is normally smaller compared to the current flow in the relay circuit. Okay, so the question is, what happened when an electric current flow in the main circuit? So the coil will become electromagnet. Okay. So this is the main circuit. You can see when current flow in the main circuit, this relay coil will become electromagnet. So what happened when it become an electromagnet? It will attract the soft iron armature above there. Okay, the soft iron, it will pull. It will pull the soft iron armature. So what happened to this part? It will be lift up. So it will contact with the second circuit or the relay circuit. So by this, it will switch on the relay circuit. Okay. So first, current flow from the main circuit, relay coil become electromagnet. Okay, then what happened? Soft iron armature is pulled, okay, to the relay coil, and this part will be lift up, so there will be a contact with the relay, and the switch is on. Okay. Okay, then what is component Q? Okay, if you zoom in the diagram, we have one component here labeled with Q. So what is the name of this component? Okay, this is what we call as a soft iron rod. Okay, Q is soft iron rod. Okay, then C suggests two methods to increase the strength of the relay. So what modification you can do to this relay system so it will be a stronger electromagnet? Increase the strength of the relay. So what you can do is, number one, increase the number of turn of coil, okay, of the relay. Increase the number of turn of coil of the relay. And second, by using a coil with bigger diameter. Okay, so both will increase the strength of the magnetic field of the relay. Okay. Okay, so that goes for question 3. Okay, now question 5. Okay, question 5 is on transformer. Okay, 5.1 shows a laminated soft iron core is wounded with insulated copper wire. An AC voltage of 240 volt is connected to the primary coil with 3000 turns of wire. And a bulb of 12 volt 60 watt is connected to the secondary coil. Okay, so the question is, what type of transformer is shown in diagram 5.1? So class, look at this diagram. What type of transformer we have here? Step up or step down? Step up or step down? Hello, Cikgu Ko. Good morning. Thank you for joining us. Okay, class, step up or step down? Okay, this is very easy. You can see obviously, yes, this is a step down transformer. Okay, step down transformer. You can see the number of turn of coil in the secondary circuit is less compared to the primary, and the voltage of the secondary also low, 12 volt compared to 240 in the primary. So we know it is a step down transformer. All right. So B, why is a soft iron core is used in the transformer? This is a very basic question, very common. Why soft iron core is used in the transformer? Yes, Vinci, Yi Heng. Okay, it is step down. Okay, yes, which one? Step down. Why use soft iron core in the transformer? Okay, yes, very good. Okay, this is 2. So because the soft iron core is easily magnetized and demagnetized. Okay, easily magnetized and demagnetized. Okay, which one? Easy to magnetize. You have to add some more. Easy to magnetize and demagnetize as well. Okay, must write both. Easily to magnetize and demagnetize. Okay, they must come together as a pair. Okay, then next question. C. Determine the number of turn in the secondary coil if the bulb light up at normal brightness. Normal brightness means it operates at 12 volt 60 watt as shown in the diagram. So how to find number of turns in the secondary coil? So earlier you are given number of turns in the primary coil is 3000. Okay, and the primary voltage is 240 volt. Secondary voltage is 12 volt. So by this, we can find the number of turn in the secondary coil. NS divided by NP equal VS divided by VP. Okay, so you just do the substitution. So we are finding for NS where NP is 3000, VS is 12, and VP is 240. So by this, the number of turns in the secondary coil is 150. Okay, 150 turns. Okay, let's go to D. Now, when the primary coil in diagram 5.1 connected to a direct current. So now we connect it to a direct current. So what happened to the brightness of the bulb? So what will happen to the bulb now if the primary coil is connected to a direct current? So what do you say? Class, what happened to the brightness of the bulb? No changes. It will be brighter, less bright, or not light up at all. The bulb will be light off. Which one? No changes. Light up brighter, less bright, or the bulb will be light off. Which one? Connect to DC, direct current. So what will happen to the brightness of the bulb? Jinjay said will not light up. Binsi said does not light up. So Zwanse say also not light up. So yes, the answer is bulb does not light up. Okay, it does not light up. Why? Why do you say so? Why you say the bulb not light up when connected to DC current, direct current? Why? What is the reason for that, for saying that? This is because when you are connecting the transformer to a direct current, so what happened in the secondary circuit? There won't be any current induced. Okay, no current induced in the secondary coil because there is no changes in the magnetic field. Yes, very good, Jinjay. No changing in magnetic field. So that's why the transformer only works with AC. Okay, that is to create a changing magnetic field in the secondary circuit. Then only can induce the EMF or the current in the secondary circuit. This one you must have to be clear with. Okay, no current induced in the secondary circuit. Or you can say because no change in the magnetic field or magnetic flux. Okay, very good. Okay, then we go to question 7. Okay, question 7 now on electronics. Okay, electronics. 7.1 show the structure of a cathode ray oscilloscope, CRO. State the process involved in producing electrons from electrode X. So what is the name of the process which emit electron from the surface of X? Do you remember the name of the process? Talking about CRO, so the process involved is, what do we call it? Yes, we call it as thermionic emission. Okay, the process is thermionic emission. Okay, yes, Aravinton. Vin Aravinton. Okay, thank you for joining us today. So the answer is thermionic emission. Okay, now B, describe the type of motion of the electron moving from Y to Z. What can you say about the motion of electron from Y to Z? Okay, from Y to Z. Okay. So before that, you have to know the label of this part. Okay, this is our heating element. And Y is our control grid. Okay, and this is our focusing anode. And Z is our accelerating anode. Okay, accelerating anode. The keyword is there, accelerating anode. So from Y to Z, what happened to the electron? How do they move? So they accelerate. Okay, describe the type of motion. So they accelerate. Okay, they do accelerate, or you can say moving with increasing velocity. Okay, or you can say uniform acceleration as well. Okay, acceleration, uniform acceleration, or you can say moving with increasing velocity. All right. Okay, next question 7. Okay, 7C. A student used the CRO to study the output voltage from a signal generator. Okay, diagram 7.2 show the trace displays on the screen and the setting of the CRO. So the cathode ray oscilloscope is connected to this screen, and you can see this is the setting. Okay, this is the time base set as 0.02 second, and this is the Y gain. Okay, the Y gain is set at 4 volt per division. Okay, so the question is determine the peak voltage of the signal generator. So how much is the peak voltage? What is the peak voltage? So peak voltage, where to look from? Peak voltage, you look from the center to the peak. Okay, so we have one division here. So what is the height for the division? 4. Okay, the setting is 4 volt per division. And we only have one division here, which means the peak voltage is 4 volt. Okay, if they ask for the peak to peak voltage, so the answer will be 8 volt. Alright. Okay, now question C2. Determine the frequency of the signal generator. Vin Arabina, skala gandaan darab amplitude ke cikgu? Betul, kamu kena darab. Kamu kena multiply. Okay, ini dia punya skala 4 volt per division. Satu kotak ni kita panggil satu division. Dia punya amplitude. So kita ada satu division saja, satu amplitude. So darab dengan 4. Okay, so you akan dapat 4 volt, 4 volt. Okay, clear Vin? Okay, now find the frequency of the signal generator. Kirakan frekuensi dia. So macam mana nak kira? How to find the frequency? To find frequency, you have to look at the time base. Time base will give you the period. Okay, so from the period, you can find the frequency. Okay, kalau you tengok gambar ini, can you tell me what is the period of this wave? Berapa dia punya period? Okay, where to look the period? This is one complete wave. Ini satu gelombang yang penuh. So we have 3 division. Okay, so 3 division. So the setting for time base is 0.02 second per division. Means 1, 2, 3 division multiply 0.02. So ini akan beri kamu the period is 0.06. Okay, but they ask us to find frequency. Dia nak kira frequency. So how to find frequency from the period? So frequency is 1 over period. Okay, so frequency is 1 divide 0.06. So by this, the frequency is 16.67 Hertz. Okay. Ini faham Vin macam mana nak kira frekuensi? Kamu kira dia punya tempoh dulu, find the period, and then from there you can find the frequency. Okay. Okay, then we go to question 3. Now you have to sketch. Okay, you have to sketch the new trace in diagram 7.3 if the time base setting is now set as 0.1 second per division. Okay, sekarang kamu ubah the setting on the time base. Okay, ubah setting saja, but our period is not changes. Okay, kita ubah setting saja, our period is still 0.06 second. Okay, so we only adjust the setting on the time base. Now, 1 division represent 0.01 second. Okay, so macam mana nak sketch trace yang baru, how to sketch a new trace showing a period of 0.06 with the setting of 0.01. So kamu lukis macam mana? You can draw a sinusoidal graph with one complete cycle. Okay, one complete cycle mean one period. Okay, so kita lukis macam ini. Y gain is no changes. So Y gain dia masih lagi 4 volt per division, still 4 volt per division. So now the wave become wider. Dia jadi besar. So from this end until to the other end, kalau you kira we have 1, 2, 3, 4, 5, 6. Okay, 6 division. So 6 division multiply 0.01. So it will give you 0.06 second, the period. Okay, period dia tak berubah. 0.06. Only the setting change. So the pattern will be changes. The wave become wider. Dia jadi lebih lebar, lebih lebar. Alright. Okay, so I hope you're clear how to do the sketching. Sama juga if they change the sketching, if they change the setting on the Y gain, you kena tengok lah. Okay, so you draw the same, the same sinusoidal graph according to the setting given. Ikut setting yang dia beri. So you just draw a new pattern. Alright. Okay, so now we go to question 9, soalan 9. Okay, this is on logic gate. Okay, shows electronic system used to switch on a security light outside a house. Okay, so what do we have here? Okay, we have an LDR, okay, light dependent resistor, perintang peka cahaya, and this is point A, point B, and point C. Okay, input A, input B, input C. And this is a gate, one type of gate here. Okay, can you recognize the name of this gate? Apa nama gate ini? Ni gate NOT and OT. Wavelength increase ke cikgu? Wavelength dia jadi panjang lah. Okay, the wavelength increases. Okay. Okay, so this is our infrared detector, sinar pengesan inframerah. Okay, the infrared detector, and this part is connect to the relay operating security light. Ini yang sambung kepada lampu keselamatan. Okay, the first question, name the type of logic gate which receive input A. Okay, what is the name of logic gate receive input A? So input A here, this is the logic gate which receive its input. So apa nama logic gate ini? This is NOT gate. The symbol you must recognize. The name of the gate with the symbol for each. This is NOT gate. Okay, 1 mark. Okay, next question B. Based on diagram 9.1, so you have to complete the following sentences about input A, B, and C by tick a right sign in the correct bracket. Okay, so first you refer back to diagram 9.1. Okay, and this is our sentences. So the first question, if the surrounding is dark, okay, bila keadaan gelap, okay, what happened to the light independent resistor when the surrounding is dark? So input A will be switch or on or off. What happened to the resistance of the LDR when the surrounding is dark? What happened to the resistance? High or low? Plus. In dark, what happened to the resistance of the LDR? High or low? Ingat, ini you kena ingat lah, in dark, dalam gelap. What happened to the LDR What happened to the resistance of LDR in dark? High or low? Nanti you kena check from your module. So what happened to input A? Okay, input A on or off? Okay, input A on or off? Input A will be off. Okay, input A will be off. So by this, input B will be so input A off, which means this is 0. Okay, and passing through not gate. Okay, so which means input B will be switch on. Chia Soon, hello, good morning. How are you? This is another one of your senior. Thank you for joining our class. Thank you for drop by. Okay, so what happened to input B, class? When A is off, which means after passing a NOT gate, input B will be switched on. Okay, input B is on. Okay, and then number 2. Okay, number 2. If a person is detected, so what happened to input C? On or off? Okay, a person is detected by the infrared detector. Okay, it will detect the heat. Okay, it will sense the heat coming from the person, from a human. So anything pass by. So if a person is detected, mean the input will be on or off. It will be switch on. Okay, it will be switch on. So this is the condition of input A, input B, and input C according to the statement given. Okay, then what happened next? Okay, the security light should be switched on if a person is detected when it is dark. Okay, you must understand this statement. Please highlight this information. The security light should be switched on if a person is detected when it is dark. Okay, so name the type of logic gate which should be used in the box marked with logic gate X. Okay, actually in the diagram, this label is missing, so you have to add in. This is where the logic gate X refers to. So what type of logic gate is suitable to be placed here? According to the situation, security light should be switched on if a person is detected. Okay, a person is detected means, okay, 1. So when it is dark, okay, also 1. Okay, so what is the type of logic gate suitable to be fixed at X? So the answer is, Vinci said AND gate. How about the others? What do you say? Maybe NAND or AND. Okay, jawapan dia AND gate. Okay, AND gate. Okay, Vin answer is AND gate. There is a person and it is dark. The situation is dark. Mean dua-dua kena satu, dua-dua kena on. Okay, so it is AND gate. Okay, now bahagian ini, truth table. Okay, yes, Dylan, AND gate. Okay, very good. Okay, now question 9. Diagram 9.2 shows the combination of 3 logic gates. Construct a truth table for the gate combination shown in diagram 9.2. First and foremost, you must know what is the name of each of these gate. Kena tahu nama gate. Okay, the gate in PQ, what is the name of this gate, class? The first gate, what is the name? This is, ni gate apa ni? With input PQ, what is the name of that gate? That is no gate. Ya, itu adalah no gate. Very good, Vin. How about the second gate below here with the input of RS? Okay, RS ini what gate? Okay, the first gate is no gate. Yes. Okay. RS, is it O? Betul ke O gate? RS itu NAND gate. Okay, that is NAND gate. NAND. Okay, NAND gate. Jingqian, yes. How about T? T. T itu barulah O gate. Vin. T is O gate. Okay, with the output T. So how to form a truth table? So this is our input. P, Q, R, and S. PQ is the input for the NOT gate. And RS is the input for the NAND gate. While T is the output for the O gate. You kena tahu. So for P and Q, this is the possibility for the input. Ini dia punya input. Either both 0, 0. Okay, both P and Q 0. Second, P0, Q1. Third, P1, Q0. Fourth, P1, Q also 1. So dia, this is the pair. Okay, the possible pair for input P and Q. Sama juga dengan R. Same goes to R. Okay, R and S, the input for the NAND gate. So this is the pair. Either both 0, 0 or R0, S1 or R1, S0 and the fourth pair is 1, 1. Ini yang basic yang you kena tahu. Okay, so you can complete with this 0 and 1 in this truth table. So what will be the output? The final output at T. Before you know the final output at T, so you must know what is the output here. You kena tahu output di sini after P and Q passing through this NOR gate. So what is the output for RS after passing through this NAND gate? Okay, so di sini apa yang keluar? Okay, with this 0, 0, so yang keluar di sini berapa? And then if 0, 1, so what will come out here? And then 1, 0, what will be the come out here? And 1, 1, what will be the come out here? So you tengok. So up here the come out is 1, 0, 0, 0. Okay, for all this pair. Okay, ini 0, 0. So 0, not 0 is 1. Okay, and then 0, 1. So 0 or 1 is 0, 0 or 1 is 1. So not 1 is 0. Okay, number 3, 1, 0. So 1 or 0 is 1. So not 1 is 0. And then the fourth pair, 1, 1. 1 or 1 is 1. So not 1 is 0. So atas ni 1, 0, 0, 0 di output. Okay. For NAND gate, first must inverse the output or multiply first. Okay, for NAND gate, you multiply first and then you inverse. Okay, itu cara dia. Multiply first and then inverse. Okay. So down here, what will be the output? Bawah sini, what is the output for RS? So RS is 0, 0. Okay, so 0, 0, 0, not 0 is 1. Okay, the reverse. Okay, then 0, 1, 0. Okay, not 0 is 1. Okay, and then 1, 0, 0. Not 0 is 1. 1, 1 is 1. Not 1 is 0. So bawah dia 1, 1, 1, 0. Okay, 1, 1, 1, 0. Okay, then this 1, 0, 0, 0 and 1, 1, 1, 0 will enter O gate. So what will be the come out? So for O gate, 1 or 1 is 1. Okay, 0 or 0, 0 or 1 will be 1. 0 or 1 will be 1. 0 or 0, so will be 0. Okay, so by this, we have complete our truth table. Tak susah kan? Cuma you kena tengok dengan hati-hati. You must be very careful when looking for all the input and the output. Okay, what gate they are passing true. You kena kenal gate itu nama apa. Okay. So Bin, are you okay? Jinjie said 1110. Yes, very good. Dylan also get 1110. Waste1 also 1110. Our final output at T. Okay, so I hope if this truth table come out in your SPM, you know how to deal with it well. Okay, kita tengok next question. Question 11. I think our final question for today, question 11. 11.1. Okay, now is to do with radioactivity. Okay, the last chapter. It shows the rate of decay of radioactive K and L respectively. So we have two types of radioactive, K and L. The sources for radioactive K and L were placed in front of a detector and the count rate were recorded every 2 minutes. Okay, so these are the graph showing for K and L. Okay. So first, name the suitable detector to be used. Okay, we have a lot of detector to be used out there. So, but which one is most commonly used to detect the presence of radioactive K and L? What is the name of the detector which is suitable to be used? Paling selalu kita guna apa if talking about detector? So the detector is GM tube. Okay, GM tube. Yes, Vinci. Geiger Muller tube. Okay, betul. Either you spell it in full, Geiger Muller tube, G and M in capital, or you can only notice GM. Okay, GM tube. Okay, next. Based on diagram 11.1, which source has a longer half-life? Okay, which one has a longer half-life? K or L? Okay, so this is the curve for K. Both are started with 200 and this is the curve for L. So which one has a longer half-life? K or L? Okay, K or L? Which one? Which one? K or L? Jinjie said K. Dylan also say K. Bin also say K. So from the graph, obviously you can see, you boleh baca daripada graph. Okay, what is the half-life for K according to this graph? Half-life for K is from 200 reduced to 100. So the half-life is 4 minutes. Okay, for K, half-life is 4 minutes. How about L? Okay, where to see L? Initial content 200. So the half-life occur when it reduced to 100. So this is the half-life. The half-life is 2.2 minutes. Okay, 2.2 minutes. So which one longer? Should be K, 4 minutes. Okay, 4 minutes K. And then number 2, they ask you to show on the graph how the half-life in 11B1 is determined. Okay, so how we determine, how we show the half-life. Okay, so we know the half-life is 4 minutes, but how to show this 4 minutes? Show mean you have to draw. Okay, so you have to draw what? You have to draw the line. From the content, 200 become half. So when the content become half, you draw a line from 100 towards the curve, and then from there you continue. Okay, you continue to the time. So this is how we show that the half-life for K is 4 minutes. You must show these two arrow. Kena tunjuk dua arrow ini. Okay, it can be dotted or it can be dashed line. Okay, no problem with that. Okay, either dotted or dashed line. So as long as you show this line to prove K is 4 minutes, the half-life. Okay. Okay, then C, you have to calculate. You kena kira the rate of decay of K that has decay after 20 minutes. Okay, please read the question carefully. They ask you to calculate the rate of decay of K that has decay, mean yang sudah hilang itu berapa, that has been gone after 20 minutes. Okay. So after 20 minutes, how many half-life involved? Ada berapa half-life? So we know the half-life is 4 minutes. So number of half-life involved is 20 divided by 4. So we have 5 half-life. So the process involve 5 half-life. Okay. So initial content 200. The first half-life reduced to 100. Second half-life reduced to 50. Okay. Third half-life, the fourth half-life, and the fifth half-life. Ada 5, there are 5 half-life. So which one is the answer? 6.25 itu ke? Is that the final answer? You read the question back. Calculate rate that has decay after 20 minutes. 6.25 is the remain content, the remain sample yang tinggal, the not decay sample. So how much decay? So you have to minus 100 minus 6.25 means the rate of decay is 93.75. Normally this one is in percentage. Okay, 93.75. In the question asked, the remain of sample left. So left is 6.25. Undecay. Okay, this is undecay, 6.25. Decay is 93.75. Okay, so I hope you are clear with this question, how we determine the rate of sample that has decay after 20 minutes. Okay. Okay, then we go to question D. Okay, now we have 11.2. It shows a system used to detect cracks in the concrete wall. Okay, table 11 show 4 radioisotopes with their respective properties. So you are design a system to detect cracks in a concrete wall. Kita nak bina satu sistem yang mengesan retakan pada dinding konkrit. Okay, table 11 show 4 radioisotopes with their respective properties. So you are given iridium 192, cesium 137, iodine 131, nitrogen 16, and they give you 3 characteristics for each. Okay, iridium emit gamma, half-life 74 days. The physical state is solid. Second, also emit gamma, half-life 31 days in a form of liquid. The third, emit beta, half-life 8 days, very short, physical, solid. And the fourth, radioisotope emitting beta, half-life 14 days in a form of liquid. Mana kita nak guna? Okay, so you have to identify first the type of radiation. To detect crack in concrete wall. Okay, so what is the choices we are given? You are given gamma or beta. So which one is a better choice? Type of radiation. Choose the one that emit gamma or the one that emit beta. So you remember our aim is to detect the crack on a concrete wall. So yang mana can work with the concrete wall? Gamma or beta? Which one? Class. What type of radiation? Gamma or beta? Senang saja ni, very simple. Okay, we choose gamma or beta. So yes, we choose gamma. Okay, radioisotope which emit gamma. What is the reason of choosing gamma? Kenapa nak pilih gamma? Why? Because gamma has a high penetrating power. Okay, it has a high penetrating power. How about the half-life? Okay, half-life. Want to use a short half-life or a long half-life? Yes, answer is gamma. Okay, gamma. Dylan, beta cannot pass through concrete wall. Okay, beta cannot penetrate concrete wall. Okay, it will be blocked by concrete wall. So we choose gamma. Okay, because gamma has a high penetrating power. Okay, yes. Okay, Arvin dah pilih dah. Siap-siap. Okay, very advanced. Half-life. Half-life short or long. Okay, remember our purpose. In certain purpose, we have to choose the short half-life. Example, in medication. Because the radioisotope will be enter our body. So it better to be short. But when you are design a system, definitely you want the system to be long lasting. Okay, so how about the half-life of the radioisotope we choose for designing a system? Okay, so we choose a radioisotope with long half-life. Okay, Arvin, untuk ini kita pilih long to design this system. Okay, the half-life is long. So why? So that it will be long lasting, can be used for longer time. If not, if the half-life is short, then you have to replace the radioisotope frequently. You kena tukar selalu, kena refill. Okay, kena refill selalu. So, kamu kena keluarkan duit yang lebih banyak. So, yes, to reduce cost, boleh juga. So, we choose a radioisotope with long half-life. The reason long lasting can be used for longer time and also to reduce cost. Accepted. Ini betul. Okay, Wei-Liang, yes. Long, reduce cost is accepted. Okay, so you don't have to spend more buying a new radioisotope every time. Okay, then physical state, solid or liquid. Which one is a better choice? Solid or liquid? The condition or the physical state of the radioisotope. It is better to be in solid. Yes, Vinci, why you say solid? Why we choose solid? Because physical state, liquid, liquid or solid? Arvin, yang mana easy to handle? Actually, solid. Okay. The state is solid and the reason is easy to handle. Okay, solid is easy to handle compared to liquid. The liquid, it can be spoiled. Dia boleh tumpah. Okay, so bila dia tumpah tu bahaya. Plus, you can see for solid, easy to store. Lebih senang untuk disimpan. Okay, compared to liquid. Liquid, you have to be extra care if you are using liquid substances. So answer is solid. Reason, easy to handle, does not spill or easy to store. Okay. Arvin, your reason is correct but your state is wrong. So dapat satu markah saja di sana. Okay. Remember this answer for this question, the answer is independent. Okay, between the characteristic and reason, they are independent. So it doesn't mean if you write the radiation wrong, you also got wrong for reason. Your reason can be right as well. So they are independent. Okay. Okay, so by this, which one is the most suitable radioisotope that can be used for the system to detect the crack in the concrete wall? So you can see obviously from the table. So which one we choose? Emit gamma, it has long half-life and then in solid state. So which one? Iridium, cesium, iodine or nitrogen? So now to make the final choice. Gamma, long half-life, physical state. So we choose, yes, we choose iridium 192. Senang saja soalan ini. Okay, we choose iridium 192. Okay, tuliskan nombor dia juga, iridium 192. Alright. Okay, so I think that's all for today. It's almost 12. So by this we have finished module 1, module 2, module 3 for the odd question. Okay, later I will post the answer to the full answer for question 1 until question 14. Actually, altogether we had 14 questions in this module. Okay, I will paste the link for the PDF, the full answer for this question later in the video description. Okay, so later on you can come back, write your name as well and your class, and you can get the answer from the link provided there. I think by noon, okay, by noon you can get the link from there. After 2 p.m. I try to put it earlier as soon as I can, so then you can get the full answer from there. And as usual, any further question, you know where to find me. You can PM me either in Telegram or in WhatsApp. Okay, yang bukan student Bagan Jaya boleh cari cikgu di Telegram. You type saja nama cikgu Hasnita. No, anything you want to ask, okay, you can ask me from there. Okay, so that's all for today. So by this, our official online lesson, the official one, has ended. And I hope what does share by your two seniors earlier, will be a good motivate for you. Student from SMK Sultan Yusof, Batu Gajah Perak. Oh, kamu kenal ke Cikgu Rizal? Cikgu Rizal ajar form 6, I think. Itu kawan cikgu juga in Academy YouTuber. Okay, so just now your senior remind you, be a morning lover. Bangun pagi, tengok dia bangun pukul berapa? Pukul 4-5 pagi bangun belajar. Your brain is very fresh at that moment, at that time. So cubalah. Kalau you okay, you can try to adapt in this new thing, because you biasa dengar early birds get the worm. So berpagi-pagi itu memang bagus. Okay, kenal. Okay. So I hope whatever shared by your senior have injected a new motivation on you. It doesn't mean you have to follow their way 100%, but anything good in it you can take. Okay, you can take as an example, as a good example, because okay, we need a new motivation in ourselves. Every day we need a new motivation. So you try to get all this motivation from different sources. Okay, absorb all the positive vibes in you, so the karma will be also positive. So you absorb all the positive thing, so only the positive will come out from you. This is what I hold to along this time. Ini yang juga cikgu amalkan. Ambil benda-benda yang positif yang orang kongsi, and we try to adapt in our life. So by then, all the positive vibes will come out from ourselves. Okay, so daripada semasa ke semasa, jika cikgu ada masa, cikgu akan adakan kelas-kelas tambahan. So you are invited to join. Kalau kamu free, you ada enough data, internet data, you can join me again next time. Okay, saya akan cubalah sedaya upaya yang boleh. Kalau cikgu ada masa, I'll try to prepare my slide, and when it was ready, I will give you the link if there is a new classes next week. Ataupun for those for my subscriber, you don't have to worry. You will get the notification, the reminder. Okay, as long as you hit the bell button. Okay, so Vin, thank you, terima kasih for joining us today. And student of Bagan Jaya, all the best to you. So you can take a short break for a while. Bolehlah rehat sekejap cuti ini. Nanti kita sambung semula. Okay, tengok bila cikgu free. I will set up a new extra revision classes for you. Okay, so that's all for today. Again, thank you very much everyone. Okay, selamat tengah hari. Okay, and have a good lunch after this. Okay. Again, Assalamualaikum for the Muslim, and bye-bye everyone. Thank you. Okay.